This video is supposed to give you a bit of an insight of how we work on digitalization projects. So in this case, we developed a model for predicting standstills in a production environment. This production environment can either be a single robotic cell, for example a robot executing spot welding processes, or an intralogistics environment transporting goods from a high-bay warehouse to different distribution places, as you can see here in a small-scale model. The basis for applying AI-based methods is good quality data. The data usually comes from different kinds of hardware components with different representations and frequencies. So we check whether there are any corrupted lines or missing data, we check the unique IDs of different data sources, and most importantly, we synchronize the data in terms of the timestamps and frequencies. After preparing the raw data, we add additional information to help the algorithm learn. So this is the point where domain experts define additional features which are basically just a different kind of representation of the raw data. So for example, we might add a feature representing the position and orientation of the spot welding gun during process execution based on the robot axis position information. Now this is the point where the machine learning algorithms use the data to find correlations within those different data sources. We use, for example, regression or classification models to predict standstills with customized forecast periods. The Navier platform of Craftworks manages the data and performs various machine learning operations. It is also used for visualizing the prediction results, so this way forecasted errors and their corresponding recommendations for actions can then be communicated to the maintenance personnel in order to prevent production downtimes.